In the world of organ transplantation, the clock is just always ticking. It's this incredible race against time where every single minute, every decision could mean the difference between life and death. For decades, it's all come down to human expertise. But what if we could give doctors a new set of eyes? What if artificial intelligence could finally help us tip the scales? To really get a grip on the stakes here, you have to start with the people. Right now, in the United States alone, over 110,000 people are on a waiting list for a life-saving organ. I mean, that's enough people to fill a giant football stadium, and every single one of them is just hoping for a phone call that will completely change their life. And the tough reality is, for way too many people, that call just doesn't come in time. It is literally a matter of life and death. Every single day, 17 people die just waiting for a lung transplant. The supply of healthy, viable organs, it just can't keep up with the overwhelming demand. So that's the big question, right? How do we turn this tide? That's what researchers, like the ones at the recent Ajmera Transplant Center Symposium, are laser focused on. They're asking, could AI be the breakthrough we've been waiting for? Can it help us make better decisions, use the precious few organs we have more effectively, and ultimately improve patient outcomes? Now, the big idea here isn't about robots taking over the operating room, not at all. It's about empowering doctors. The goal is to create these incredibly powerful AI assistants that can sift through enormous amounts of data, see patterns that are pretty much invisible to the human eye, and give doctors insights that are, well, almost superhuman. Okay, so let's get specific. Let's start with kidneys. At the symposium, a researcher named Dr. Alexandra Lupi from Paris talked about this incredible system called iBox. Its job sounds simple, but it's revolutionary: to look at a donated kidney and predict how well it's going to do long-term inside a new patient. So think of the iBox system working in 3 different layers. First, it crunches all the standard info, donor's age, medical history, all the usual stuff, and creates a score. Then, for the second layer, it adds in really cutting-edge data, like donor-derived DNA. And finally, the third layer uses AI to look at the kidney tissue with what they're calling a molecular microscope, giving a level of detail doctors have just never had before. And get this, it's so effective, it's already being used in 44 centers all around the world. Okay, so what about lungs? This is where Dr. Andrew T. Sajana's team come in with a model they call Insight X. And the best way to think about this is that the AI literally interviews the lungs while they're being kept alive outside the body on a special machine. And believe me, this is no simple interview. The AI is analyzing over 100 different variables in real time. It's looking at everything: cytokine production, lactate levels, electrolytes, airway pressures, you name it. It's a fire hose of data that would just be impossible for a human team to make sense of, especially under that kind of pressure. So the big question, how well does it actually work? Incredibly well. The model hit an astonishing 90% accuracy in correctly identifying lungs that were not suitable for transplant. Just think about the impact of that for a second. It could prevent a potentially fatal transplant failure before the surgery even starts. But, and this is a big but, with all of this amazing promise comes a really profound challenge. It's what people call the black box problem. Sometimes an AI can give you the right answer, but for all the wrong reasons. This is where you find the ghosts in the machine. This is the absolute key question that developers have to ask themselves. As Dr. Mike Brudno from the University of Toronto pointed out, if you don't know how your AI is thinking, you can get into some serious trouble. He gave this perfect example from his work with chest x-rays that really drives the point home. So his team built an AI to spot a collapsed lung, a pneumothorax, from x-rays. And on the surface, it seemed to work great. But when they dug deeper, they found this shocking shortcut the AI had learned. It wasn't actually identifying the collapsed lung at all. No, it was just identifying the presence of a chest drain, which is the treatment for a collapsed lung. You see the problem? The AI had learned this clever but totally useless correlation. It was a huge wake-up call that without really rigorous checks, these systems can easily fool us into thinking they're smarter than they are. As Dr. Brudno himself put it, the model was erroneously determining causation from association. And in the high-stakes world of medicine, that is a mistake you just can't afford to make. Okay, so this brings us to the final and maybe the most important piece of the puzzle. It is not enough for an AI tool to just be technically brilliant. It also has to be designed for the actual humans, the doctors, the nurses, and the patients who are going to be using it every day. Dr. Joseph Cafazzo from UHN made this point so powerfully. He said it's not just a product, but an experience that is being designed. Technology in healthcare so often fails when it doesn't take into account human factors and workflow and, frankly, just a little bit of empathy. But when you get it right, wow, the results are stunning. Take the Medley app, for example. It's a tool that was designed with patients to help them self-monitor their heart failure. It's simple, it's intuitive, and it was built with the user's actual experience at the very center of its design. And the result? Since it launched, the Medley app has been linked to a 50% reduction in hospitalizations for heart failure. 50%! That just proves that this isn't just about good design. It's about saving lives and taking a huge burden off the entire healthcare system. So where do we go from here? When you tie all these threads together, the path forward for AI and transplantation isn't about finding one single magic algorithm. It's about building a trustworthy ecosystem where doctors and AI can genuinely work together, side by side. And according to the experts, that path requires a few really key things. We need massive, diverse data sets to make sure our models aren't biased. We absolutely need transparency, what we call explainability, so we can trust how the models are making decisions. We need tons of clinical trials, updated regulations, and, of course, a constant focus on human-centered design. Because the ultimate goal here is actually a really hopeful one. It's to use AI to handle all the overwhelming data and paperwork, freeing up our physicians to do what they do best: connect with, listen to, and truly care for their patients on a human level. This technology is moving at a breathtaking pace. It's promising a future with more successful transplants and longer, healthier lives for so many people. But it leaves us with one final and really crucial question to think about. As this artificial intelligence gets smarter and smarter, how do we, the people creating it and using it, make sure that it also stays wise?